Alright, this might be a little bit easier because I have the graph paper, or the grid there. So it'll be easier to count the slope and get an accurate slope. That I didn't have in the other example, but this might clarify things if you were confused about that one point that was like not part of the graph. So here's to clarify. Alright, I'm going to pick a few x values. I'll start it over here. Okay, what am I doing? It's going to be red. So this entire line has the same exact slope. So really from, what is this, negative 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yes. So I'm going to say from negative 10 there, all the way until negative 1, negative 2, I'll say negative 2. All the way from negative 10 to negative 2, we have the same slope. What's that slope? I'm just going to get something that's close. I don't know if it's going to be perfect, but I'm going to count the slope there. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Alright, there's slope of 1. That's how you get an accurate graph for the slope. And I'm going to get rid of that huge there. So what was it? Negative 10, negative 2. That's a slope of positive 1 and positive 1. So those two values, that just represents from everything in the middle as well. Okay, great. Here's the problem. We have a corner here. The slope on this side is 1. The slope on this side is 0. So at negative 1, there is no particular slope, because if you remember from the limit definition of the derivative, as h approaches 0, we're going from both sides. So I guess f of x plus h, I'll just write the whole thing, minus f of x, all divided by h. If we're choosing our x value to be this, then our h could be positive or negative, because we're approaching from both sides. Because h from the left side would be 0, negative, h from the right side of 0 would be positive. And so that means we're approaching this from both sides. If the limit doesn't agree from both sides, then we actually don't have the derivative, because it's by definition a limit. So on this one, I'm going over this really fast. Hopefully you can understand it. So at the corners or cusps, we don't have any derivative. So I'm going to say at negative 1, we'll say undefined. No, that kind of means something else. We'll say not differentiable, because there is no derivative there. So same thing happens at 1, 2, 3, x equals 3. At x equals 0 and everything in between, the slope is 0. That's all of that stuff, all the way up until 3. And we can say not differentiable. That just means it does not have a derivative there, so you can't take the derivative there. You can't find the slope there, because it disagrees from the left and the right. And then, oh boy, I'm going to do this in green. So I'm going to pick this point. So what was this? 1, 2, 3, 4. So I'll say, at 4, what is the slope? So at 4, I'm going to try and draw the best tangent line that I can. That's, I feel like, the best that I can do. And then, what am I going to do? I'm just going to calculate the slope of that tangent line. If I have graph paper, it should be pretty simple. And you can draw on the papers that I give you, so there you go. What is this slope? Negative 1, 2, 3, 4 over 1, 2, 3. Negative 4/3. So here I'd have negative 4/3. Then I'll have a really accurate graph of the derivative, which is this, f prime of x. Okay, I'm going to pick another point. And I could just pick all of these, and maybe I will. I'll do that now, and then I'll write them all down. So I'll pause it and do that. Well, maybe I won't pause it. I'll show you. So I'm graphing the derivative there, which is the slope of that, kind of. Do the best that I can. That's a pretty good tangent line. So this is for this one, x equals 5. I'll pick that point, and look at that. That looks good. Down, so that's a negative 1. So at x equals 5, we have negative 1. So that's 4, 5, 6. Let's see that. It looks maybe there, and I don't know where to pick. Oh, I guess we'll do that. So what is that? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Negative 7. Negative 4 over 7. Sorry. This gets really tedious. You could just think about it, but we'll keep doing this. What is it? 4, 5, 6, 7, 8. At 8, I'm skipping some because I want to move on. At 8, the slope is close to 0, so I'm going to say 0. And then it becomes positive. I'll just say this is a positive 1 at 10. Okay, now we have something that's a lot more accurate than the last example. And I'm going to graph it here and in green. And now I'm just plotting points. Negative 10, 1. Negative 2, 1. Negative 1, I'll put an open hole. Same with that. Because it's not differentiable, I don't have a derivative. So let's see what this looks like. Negative 10, comma 1. Cool. Negative 10, comma 1. Negative 2, comma 1. Oh yeah, it was 1 the whole time. So negative 2, comma 1. So that means the derivative is just a flat line. Some people are thinking, that's a 0 slope. We're not thinking about the slope of this. We're thinking about the slope of that, silly. And then, well, I guess it goes all the way until that. So I'll put a hole at negative 1. And it has a slope of positive 1 all the way up until this corner. And then I got a slope of 0 again, so this will be an open hole. Slope of 0 all the way until 3, I suppose. Oh, 1, 2, 3. So I'll put it open there. So it's a piecewise function. There's a jump discontinuity for the derivative because we don't have derivatives there. Okay, the slope jumps from a 1 to a 0. So it should jump from a 1 to a 0 for y values. Oh, this is making sense, maybe. I don't know. What is this? Negative 1.3 repeating. So this would be 4 at 4. Well, I guess at 3. At 3 I do this. Negative 1.3. So negative 1.3, something like that. But this, I'll have an open circle as well. Because, again, I have to. That's at 3. And I'm just going to assume that it's almost the same slope. So at 4. At 5, we have negative 1. At 6, we have, what is this? Almost negative 1/2. So what is this? 1, 2, 3, 4, 5, 6. Is that 6? Yes. Almost 1/2. I'm just going to do as best I can. At 8, we have a slope of 0. So that was at 3, 4, 5, 6, 7, 8. We have a slope of 0. At 10, we have a slope of 1. So this should look like kind of like that. Maybe it's a line. It probably is a line. So that's the graph of f prime of x. I hope that makes sense. Just broke it down. This continues to go upwards, so the slope maybe continues to be the same. I don't know. We'll see. Or no, we won't see. But hopefully this makes sense. You have some homework problems like this, so that's why I'm doing it, of course. But this is also on the AP test, and it's important to be able to look at a graph and decide what the derivative is. That's what we're doing, really. So we're just looking at a graph and thinking about the slope of that. And this is just an intermediate step to write it down. All right, there you go.